Hello everyone, this is the video lecture for pre-calculus. We're doing 5.1 degrees and radians. So let's just get these formulas out the way to start with. My degrees is equal to radians times 180 degrees divided by pi. And radians is equal to degrees times pi over 180. All right. So how do you know which one goes with which, right? How I think about it is when we're converting degrees and radians and all that kind of stuff, I have, I don't know, let's say 30 degrees, and I'm going to multiply it by something. So if I multiplied it by 180 over pi, notice that I'm going to have my degree symbols don't cancel. Also, I have a pi in the bottom, which is kind of weird. Not impossible, but kind of weird. But what if instead I multiplied it by pi over 180? So if I had that, then my degree symbols cancel, leaves a pi, and then it makes sense. So we would have, in this particular case, 30 degrees over 180 degrees, and you got a pi, and it ends up being pi over 6. So that's the idea here. Now, we all know about degrees. Let's talk about radians. At this point, you should basically know what these are because this is pre-calculus. You've already gone through Algebra 1414, and I totally recommend watching the 5.1 lecture on 1414 because it's the same material. It literally is the same questions, 100%. I don't even know why I'm making this video, but I'm doing it anyways because I like you guys, so here we go. So let's start with degrees. We all know degrees very well. If you go around a circle, you start at 0 degrees, you go all the way, it's 360 degrees, you have 90, you got 180, and you got 270. Okay, cool. So let's talk about radians. So radians are a little different, and I know you've probably seen them, but might have forgotten them, and that's totally fine. So 0 radians is right here. This is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians. And this is 2 pi radians. So 2 pi radians is a full circle. 2 pi is the same as saying 360 degrees, essentially. Cool. Why are we using radians? Well, they're actually really useful both in calculus as we continue onward, and it's also really cool when you're doing arc lengths, finding angles, areas, and like basically real world problems. So that's why pi was even found at all, why it was like used, is because it's actually a useful number. Degrees is cool and it's easy for us because we've grown up with it, but the radians is actually practical in the real world. Anyways, so what we're really wanting to do in this section is convert back and forth, but I want to show you a couple more before we're done. So this is quadrant 1, and in particular, I'm going to use these, I guess, special angles. And so I have 30 degrees, 45 degrees, and 60 degrees. And so the equivalent for these would be pi over 6 radians, pi over 4 radians, and pi over 3 radians. Now, these are very common. They're important, and you should definitely memorize them at some point. This quadrant 1 business here is part of the unit circle, and if you got this quadrant, then you can get all the other quadrants really without any problem, okay? But that said, let's keep going. We have one last thing I have to do before homework is a formula for arc length. And the formula for arc length is S is equal to R times theta. Now, theta is in radians. If you don't have it in radians, it basically won't work. So we've got to convert it before it'll actually make sense. S is your arc length, and R is your radius, and theta is your angle. Again, that's theta. I know you probably know this stuff already, but I'm just reminding you. Theta, it means angle. It's a Greek letter that just means angle for us right now. Okay. So again, one last thing, when it comes to arc length, let's say I have like some kind of angle here. I'm just going to say that's about 135 degrees. Well, S is this arc length right here. R is how far out it is. Theta is your angle. So S is the whole like that arc length. How much distance did you travel essentially? Okay, now let's do some homework problems. So 517, it says R is equal to 40. It says S is equal to 70. And it says, what's your theta in radians? And so what I'm going to do here is follow the formula and be done with it. It's very simple. We have 70 is equal to 40 times theta. How do we solve for theta? We divide by 40 on both sides. You got it. That's right. Sorry. It sounds a little silly, I know, but I mean, it really is very simple. What they're wanting for their answer is 7/4, and this is radians. Now, where is 7/4 radians? Just if you go and do the math for it, 7/4, I believe, is 1.75 radians. And if you're using decimals, then this is 0, this is 1.57, this is 3.14. Remember pi. So 1.75 is somewhere about right here, probably. 1.75. And so your arc length here, given that your radius was 40, and this must be a 70, and so then you got about that much angle. There you go. Yay! Next question. So 5, 1, 13. We have 65 degrees is equal to blank radians. And so I'm just going to convert it. Now, again, I'm always wondering what I'm multiplying it by. I don't get this right all the time. But I like, if I mess up, like, oh, it's 180 over pi, right? No, hold on. My degrees aren't canceling now, and I got a pi in the bottom. That's kind of weird. Let me try the other one. What about pi over 180? Oh, yeah, I see it, because you're right. The degrees will cancel. So I really do that every single time. And I don't mess up every time because half the time I get it right. It's one way or the other, right? Anyways, so this is my numbers that are going to be in the front, and I need to simplify that in order for MyMathLab to accept it. I would just use a calculator. Desmos Scientific will just reduce it down for you automatically, and there you go, radians. Okay, super easy. Let's do some more of this. Just more practice. Again, I gotta say, the 5.1 video lecture for the 1414 series is identical to this. I'm doing this just because I like you guys. But if you want a lot more examples, if you want to see this all over again, that's where you got to go. Okay, so I got another degrees, and I'm going to multiply it by pi over 180. Yep, that's right, because I cancel my degree symbols. Everything's cool there. Putting these numbers together into the calculator, I get -7/2, and that's good enough. We're done. Next problem. All right, so 5, 127. I've got -13 pi radians is equal to something blank degrees. So this time I'm going backwards from what I've been doing. As an idea, I could say, oh, well, I'm going to do pi over 180, just like all the other times, right? Well, hold on. My degree is in the bottom. It needs to be in the top. And notice, are these pi's going to cancel? No, they're actually going to combine. You would get like pi squared something divided by degrees. None of that makes sense. So again, I messed it up. I probably did the wrong one. 180 over pi, is that right? Okay, so I cancel my pi's and I have a degree symbol now. Yay! Yeah, that's right. So what we're going to do is -13 times the 180 degrees. When you put it in the calculator, 2,340 degrees. So there you go. Cool. Again, I'm just trying to show you all the different ways that I mess up, and then I try to make it better. So I have this many radians, and this time they say graph it. So it's like multiple choice, basically, and we're trying to find what it looks like. Very simple. Let's just say you have a unit circle with you. You can go and find this right here on the unit circle, and then you're done. Or you could convert this into degrees, and so that we can see exactly where that is. The pi's are going to cancel. Degrees symbol sticks around. I do the math. Actually, I don't have the math done in my notes, so yeah, hold up. Let me do a calculator. And I've got 240 degrees. So 240, this is 270 degrees right there. So 240 is about right here. And so I just did this. Remember that we always start here at 0, and we're going to go counterclockwise. These kind of things we're going to see a lot more as we keep going, but I just have to remind you that stuff. All right, let's do another one. 5, 1, 47. So I got negative 5 pi over 3 radians. And they say, graph it again. Again, if you had the unit circle, you're done. You just go and find it. The only difference is that you have a negative this time. So you're going to go clockwise rather than counterclockwise. Anyways, converting this, and again, you multiply and blah, 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 blah. I believe you get 300 degrees. But it's, of course, negative this time. Okay, hold up. Let me actually try and double check. Yep, 300. Okay, we're good. So, yeah, you just multiply it same way we just did it. Okay, cool. So 300 degrees. Where is that? Well, normally 300 degrees is down here when I go counterclockwise, right? But that is not the case this time. This time we're going clockwise because it's negative. So it should be up here. We did this. That's clockwise. Okay, 300 degrees. Awesome. They're going to ask about what quadrants they are in. What quadrant's this guy? Quadrant 1. You got it. I even paused there so that you could answer. Anyways, the next question is kind of like a word problem. Not really. It says find the positive angle that is less than 360 degrees, and it's also coterminal with, and this is the big one, 430 degrees. Okay, so 430 degrees, where is that? Well, this is 360. I don't know, something up here. No clue. 430 question mark? I don't know. It's somewhere out there. The reason why I don't know is because it's past the 360 degrees. If it were within the 300, if it were less than 360 degrees, then it would make more sense to me. And so what I'm going to do is I'm going to subtract 360 from it. So that way I can reduce it down some. Like I don't need to tell how many times I'm going around the circle. And I just want to know where's it stopping. Coterminal is, it looks like the same answer in the end. So I'm going to subtract those, and I got 70 degrees out of it, which, yes, indeed, looks just like that. So there you go. That's your answer, 70. There it is. So the idea with coterminal is that you're going to keep adding or subtracting 360 until you get the same, until you get an answer that makes sense. So now they're going to say coterminal with negative 805 degrees. So because it's already negative, what happens is that you're going clockwise a whole bunch, and I don't know where you stop. It doesn't really matter. I don't want that. I want to start getting it into around 360 degrees. So I can't subtract 360 this time. I add 360 because it's reducing it down. It's taking it from the negative into the positive. And so I got negative 445. Still not recognizable. I need to keep going. So negative 445 plus the 360. Just using my little calculator here. I got negative 85. Now, that should be good enough. Like, you should be able to figure out where negative 85 is. But I'm going to keep going because it's going to ask for an angle that's between 0 and 360. So add 360, 275 degrees, which definitely I can use. So where did it end up? That doesn't look like that. It actually ends up being about right here. And so it was negative, so we went around and around and, I don't know, something like that. Doesn't really matter. It ends up right there. There's your answer. You're done. Okay? Cool. 5,163. My sixes don't look very good today. So it says coterminal. Same problem. With 13 pi over 4. Awesome. So now instead of using the 360, which we're used to, we're going to use 2 pi because they're the same thing. So you're going to add 2 pi or subtract 2 pi. In this particular case, it's a bigger number, it's positive. I'm going to be subtracting 2 pi. Now, I did it like this because it's actually way easier to see. I've got blankety blank pi minus blankety blank pi makes a blankety blank pi. I mean, it's just going to be another pi answer. What we're really concerned about, I'm going to use a different color here. I'm going to show you. I'm really only concerned about that. So do that in the calculator so we can get a number. Don't put your pi's in the calculator because you'll just get decimals and weird stuff and it won't end up being a nice fraction. Just do the regular number math. And then you just slap a pi on there. 5 pi over 4, that's your answer. Now, what's happening is, where is that? 5 pi over 4, so this is 0. 1 pi over 4 is 45 degrees essentially. 2, 3, 4, 5. There you go. So it went that way. Of course, this went around the whole other circle and ended up there, but I'm only concerned about where it ended up. All right, next question. 5171. So I have a radius of 14 inches, and then I have a theta of 165 degrees. And it says, what's your arc length in inches? So the classic way to solve this problem is, oh, well, I have my 14 radius. I've got 165 degrees. I multiply them, and I get an answer. Here, I'll even do it here. This is classic right here. Classic. 2,310 inches. Totally wrong. Yeah, that's right. This is not the way to do it. How do I do this problem? It's 14 times 165 times, here it is, pi over 180. Now, why did I do that? Well, because this was degrees, and now I'm converting it into radians. Remember, theta's got to be in radians. So I'm just converting it inline. I'm converting it all at once. And so in the end, this does want both exact and the decimal equivalent. So I'm going to type all that stuff into my calculator first, okay? Give me a second here. And I got, well, I have a fancy calculator apparently. Cool Casios. You should not be using this. This particular Casio, I have a FX 115, which is the best calculator ever. And it's a scientific, it's not even a graphing calculator, but it's not allowed on the exams because it's just that cool of a scientific calculator. Desmos Scientific is totally cool and it's great, but like, come on. When you type this and you get that, haha. Now, how do you get that on Desmos Scientific and all the other ones? You just use the numbers. I mean, it's not really a big deal. My calculator just said, oh, let's just toss the pi out there, and the rest are just numbers. That's all my calculator did. It was easy. But I also do need the decimal equivalent, and that is 40.3171. And again, this is all in inches. So part A, part B, there you go. No problem. Keep cruising. So I'm just boasting on my cool calculator that would cost like $10, and it's just the best thing ever. It'll take you through Cal 3. No doubt in my mind. This has got to be one of the weirdest problems. So they give you this kind of circle with 3 little dashes here and a dot. And it says find 2 angles that are coterminal and that are between negative 2 pi and 2 pi. Okay. What? That's all it says. Go. Well, you're going to have to assume that that guy is at 45 degrees. And it's so sad that it just says, figure it out. So I'm telling you that this is trying to be like unit circle 30, 45, 60. That's going to be a 45. So first off, let's convert the 45 into radians. It's pretty simple. I'm going to multiply by, I'm waiting for you, pi over 180. Let's try that. So the degree symbols cancel, multiplying all this stuff, blah, 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 pi over 4. Or I guess in your calculator you got 1/4, so 1/4 pi. Either way, Oh, zoom in. Anyways, this is good. We're good there. No problems. I actually do want to zoom back out. That was just a mistake. So, okay, cool. So I like that. That's great. That's one of my answers, but it wants two answers, and so that's a positive, and it says it can go negative. And so what I'm going to do is I'm going to take my pi over 4, or rather, I guess in this case, a 1/4 pi, and I'm going to subtract 2 pi. What's happening is that I have a 45-degree answer. Cool. But if I go, like that's what a 45 is. But if I go a whole other round, I'll be past the 2 pi. So I don't want to add 2 pi because then it's way too much. Instead, I'm going to go backwards 2 pi, still end up here, okay? But at the same time, I'm within their constraints. So blah, blah, blah pi minus blah, blah, blah pi is equal to blah, blah, blah pi. This is what you're doing in the calculator, and I think we get a negative 7/4. And again, let me just double check. Your Desmo Scientific will definitely convert it into fractions for you. So there you go. Cool. There's your two answers. We did it. Put a comma between them. 5/179. This is a repeat of the same problem. One thing in particular, though, is that they've changed it. There's the 3 tick marks here, but the dot is right there. So we have to know that this is 330 degrees. Unfortunately, they're just not going to tell you that. You just got to know. So I'm telling you. Great. So 330 degrees. If you go and convert it, again, you can use a unit circle for all this stuff. But this will be a pi over 180. Blah, blah, multiply, and you get 11 pi over 6 radians. So there's one of your answers. And you know what to do, just like the last problem. I'm going to subtract 2 pi. Again, I'm doing all this in the calculator, and you're going to get a pi. Negative 30 degrees, so negative 1/6 pi. And so there's your other answer. Cool. I got 3 more problems left. So 5/189. This is called the clock problem. And if it has a name, it means you need to pay attention. So here we go. Clock problem. I'm just going to draw you what a clock looks like. There's your, I don't know, there's some hands there. So we got 12, and then we got 1, we got 2, we got a 3, 4, 5. This is going to be important in a second. 6, 7, 8, 9, and then I got a 10 o'clock, 11 o'clock, and then back to 12 o'clock. So that's a clock. Didn't you know? It says that we have a minute hand that is 10 inches long, okay? And it says it moves that minute hand from the 12 o'clock position to the 8 o'clock position. And so you're just taking the minute hand, that one I guess, and you're going, actually that can't be the one because we're going from 12. And so I'm going to go from 12 all the way to 8 so that it looks like it's right here now. Okay, so that's what we're doing. Sounds great. Sorry for that plane that went by. And then how far does the tip of the hand move? What they're asking for here is S equals R theta. They're looking for arc length. Okay. So they're wanting the arc length. We got a radius. Oh, radius is 10. Awesome. But what is my theta? And I remember doing this in class, and it was a little different than the way I'm going to do it here. But either way, what I'm going to do is I'm going to multiply my 2 pi is a full revolution. But then I'm going to multiply it by 8 over 12. What I'm doing here is I'm saying this is 1 full revolution. But then I'm not going a full revolution. I'm only going 8/12 of the way. I'm going 8/12 of a full revolution. Okay? And notice that that's going to stay in radians. The way I did it in class was I converted to degrees, and then I did all that stuff. And then I had to convert back to radians. It was actually kind of meh, in my opinion, but it does work. I say that this is much faster. So 40 pi over 3 is my answer, and they do want it in exact answers. So that is the answer. There's nothing else to do. You're good. 5195. Okay. So I have a picture of Earth. That's right. And right here we have city B, and here we have city A, and from the center of the Earth, they're connected and they have an angle between them. What they're wanting here is the distance between these cities on the surface of Earth. Okay? So let me give you some answers. So I got theta, the angle right there, is 35 degrees, and it says the radius of Earth is equal to 4,000 miles. I think it's like 3,960 or something, but 4,000 is super easy to do. And so we're still looking for S equals R theta. We're still looking for our arc length here. So very quickly, I could say it's 4,000 times 35 degrees times, and then we're going to convert it over pi over 180. Okay, that sounds awesome. But I just want to do it in 2D just to show you what's really going on here. This is B, this is A, there's my center, and they say, hey, this is 35 degrees here. So then what's my arc length between them on the surface? Blah, blah, blah. You type all this into the calculator. I got 2443.46, and then this is in miles. So there you go. One last question, and this one's super easy. 5199. Wow, those nines look terrible. They just look like sticks. Come on, Chad, put a little bit more effort into it. So, it's okay. So this is a water wheel problem, the water wheel. And I'm going to show you what a water wheel looks like. I did not do this in my notes, but, well, I know what a water wheel looks like for myself, so I didn't have to do that. There you go. Kind of looks like a gear, kind of. There you go. And water's falling right here, and then it spins it. So that's a water wheel, and it's kind of like sitting in water. Okay, cool. So we got a water wheel, and it says that the radius of this water wheel is equal to 16 feet, and then it's rotating at 20 revolutions per minute. 20 revolutions per minute. Kind of slow. And it says, what's the linear speed? Okay. What they mean by linear speed is how fast is it at the tip here? How fast is it traveling? And so they're going to want it in feet per minute, essentially, because we talk about feet and minutes here. So it's still, because it's on the tip, we're talking about arc length, S equals R theta. But now my radius is 16, so that's pretty easy. My theta is kind of different. So I'm going to say it's 2 pi for one single revolution. Okay, so a 2 pi is one revolution. Okay, I guess you could say it's like radians per revolution. And I'm going to multiply it by the 20 revolutions per minute. What happens is that you cancel out these revolutions, and you're left with radians, which that's what we need for theta is radians. And so you multiply that straight across, and so you get 16 times the 2 pi times the 20, and then your answer would be, just doing the calculator right quick, 2010 and 619. So there you go. And this is again now revolutions. No, sorry. This is feet per minute. Again, because this is definitely a feet right here, so we're keeping the feet, we're keeping the minutes. Radians kind of just disappears because of the formula, just disappears. So there you go. Cool, and that's all I've got. So thank you very much, and have a great day.